What if one day our solar system were no longer in its peaceful corner of the Milky Way and were placed near the supermassive black hole at the center of our galaxy? Imagine that the Sun is no longer the main focus of the story, and that Earth, Jupiter, Saturn, and the other planets appear in a much more extreme, denser, and more dangerous region. In this simulation, our system is not in its natural place, but rather around S2, a real star orbiting very close to Sagittarius A*, the enormous central black hole of the Milky Way. From the very beginning, a disquieting question arises: would Earth still look like Earth? Would the sky be brighter, darker, or more threatening? And, above all, could a planet survive in a zone where the gravity of the galactic center controls the movement of entire stars? The real answer is that this couldn't be done naturally with our solar system. Planets can't simply be ripped from their orbits and placed around another star without destroying the balance that keeps everything stable. Earth exists in a very specific region around the Sun, with a speed, distance, and gravitational history that allow for its current orbit. But as a simulation, this idea is powerful because it allows us to imagine how our view of the universe would change if Earth were near the center of the galaxy. To get there, we would have to travel some 26,000 light-years from our current position, through the Orion Arm and deeper into the Milky Way. Every point of light that passed before us wouldn't just be a decorative star. It could be an entire system, with planets, moons, and perhaps unknown worlds. Even if the camera traveled at an impossible speed, much faster than light, the galaxy would still appear immense. And that's important. That speed doesn't represent an actual journey, but a visual tool so that we can understand a distance that the human mind can hardly imagine. Simply put, this first part isn't about actually moving the Earth or turning science into fantasy. It's about using a simulation to ask a huge question: what would our planets look like if they were in one of the Milky Way's most extreme regions? Sagittarius A** is real. S2 is real, too. And the galactic center exists at such a vast distance that light takes thousands of years to travel from there to us. Sagittarius A** has a mass roughly 4 million times that of the Sun, but it shouldn't be imagined as a bright ball chasing planets. A black hole doesn't shine like a star. Its power lies in its gravity, in the way it bends light, alters the motion of stars, and marks the invisible heart of our galaxy. So, in this story, the real fear isn't just falling into the black hole. The real wonder lies in understanding that if Earth were there, the entire sky would change. There would be more dust, more stars, more movement, and a constant sense of looking into a region where the universe becomes much less familiar. And this is just the beginning. Because once we imagine Earth near the center of the Milky Way, even something as simple as a sunset could become a completely alien scene. If you enjoy journeys where real science blends with stunning simulations, subscribe to the channel, like this video, and comment. Would you like to see Earth's sky from near a black hole? What if Earth survived the journey, but the sky above our heads no longer looked like the sky of our home? Before continuing, like this video and comment Galactic Center if you want to see more simulations where familiar worlds are taken to impossible places in the universe. Now imagine we are standing on this new Earth. At first, everything might seem familiar. The ground would still be beneath our feet, clouds might drift across the horizon, the oceans would reflect the light, and the planet would still have that familiar blue hue. But we would only need to look up to understand that we are no longer at home. The sky would be different. Much heavier, deeper, stranger. Instead of the tranquil sky we see from our current position in the Milky Way, we would be looking at a much denser region, filled with stars, dust, and gas. The light might have a yellowish or reddish tint, not because the Earth has changed internally, but because the space around the galactic center is filled with interstellar material that scatters and blocks some of the visible light. And somewhere in that sky, invisible like a shadow with immense power, would be Sagittarius A*, the supermassive black hole around which this extreme region is organized. But it's important to understand something here. A black hole doesn't appear as a bright star in the sky. It's not a sphere of fire or a cosmic lamp. The event horizon of a black hole is precisely the boundary beyond which light can no longer escape. That's why, if we looked towards Sagittarius A*, we wouldn't see a luminous surface like the Sun. What we might perceive would be far more unsettling. a dark area surrounded by distorted light, stars warped by gravity, and perhaps faint signs of hot gas moving in its vicinity. Its presence wouldn't be powerful because it illuminates, but because it bends light and alters the entire scene. This is the difference between fantasy and science. The black hole doesn't need to shine to dominate the picture. Its gravity is enough to transform the sky into something completely unfamiliar. Even from a safe distance, the idea of seeing such an object on the horizon would forever change how we understand space. Simply put, the planets wouldn't magically change just by being in a different location. Earth would still be rocky, Jupiter would still be a gas giant, and Saturn would still have its rings. But the environment around them would be entirely different. Imagine Saturn's rings stretching out like a shimmering structure, with the denser center of the Milky Way appearing behind them. Imagine Jupiter, enormous and storm-strewn, floating in a region where stars seem more abundant and the galactic background appears more intense. The planets would be familiar, but the universe around them would no longer be. That's the power of this simulation. It doesn't show us new planets, but our own planets in a setting that seems to belong to another universe. The true beauty lies not only in zooming in on Sagittarius A*, but in seeing how something familiar can become completely alien when its place in the galaxy changes. But the most unsettling part is yet to come. Because after seeing Earth, Saturn, and Jupiter under this impossible sky, the journey takes us to a much deeper frontier, the limit where light can no longer return. There is a boundary in space where all paths lead inward. Once something crosses it, not even light can return to tell us what happened. If you think black holes are one of the greatest mysteries of the universe, like this video and comment, Event Horizon. Do you think a black hole is the absolute end, or a gateway to something we don't yet understand? Now we leave Earth, Saturn, and Jupiter behind, and the camera begins to zoom out. For the first time, we no longer see just planets transformed by a strange sky. We see the entire galaxy as a vast island of stars swirling in the darkness. The Milky Way ceases to be a simple band of light in the night sky and becomes an immense structure, filled with spiral arms, dust clouds, bright regions, and billions of stars. And then a deeper question arises. If our solar system can appear so small in this simulation, how many other worlds are hidden in that immensity? Perhaps there are planets with oceans, frozen moons, strange atmospheres, or skies that no human eye has ever seen. Perhaps, somewhere in this same galaxy, other beings are also looking up and wondering if they are alone. At that moment, the journey ceases to be just a visual simulation and becomes a way to understand our true scale in the universe. Then the camera turns back to Sagittarius A*, the supermassive black hole that marks the gravitational center of the Milky Way. It's important to clarify something. Sagittarius A* isn't the largest black hole in the universe, nor is it one of the most active. In fact, compared to other supermassive black holes that devour vast amounts of gas and produce enormous jets of energy, Sagittarius A* is relatively quiet. But that doesn't make it any less important. Its mass is so enormous that nearby stars orbit around it at extreme speeds. It's as if the entire galactic center is obeying an invisible presence. We don't see the black hole like we see a star, because it doesn't emit light from its interior. We know it by what it does, by the way it moves stars, bends light, and controls the space around it. That's why the scene becomes more serious. We're no longer looking at a beautiful landscape. We're approaching a region where gravity becomes so intense that the normal rules begin to feel strange. Simply put, the most mysterious aspect of a black hole is the event horizon. This boundary isn't a solid surface, nor a visible wall floating in space. It's an invisible frontier. Before crossing it, there's still a chance of escape if you have enough speed and energy. But once something crosses over, it can't return. Not a spacecraft, not a signal, not even light. That's why we don't really know what happens inside. We can study what happens around the black hole, the movement of stars, the hot gas, the distorted light, and the effects of gravity. But the interior remains hidden because no information can escape from there to reach us. And therein lies the true mystery. A black hole isn't simply an object that swallows things. It's a region where space and time behave in ways that defy our intuition. From the outside, We can measure its effects. We can calculate its mass. We can observe how it alters its surroundings. But beyond the event horizon, our questions go beyond what science can directly confirm. What would someone experience crossing it? What happens to matter inside? Is our current physics sufficient to describe it, or do we need a deeper theory? That's why Sagittarius A* isn't just a dark spot at the center of the galaxy. It's one of the strongest signs that the universe still holds secrets we haven't yet unlocked. And after seeing how Earth, Saturn, Jupiter, and the entire Milky Way change in the presence of a black hole, one final question remains. What does this impossible journey teach us about our true place in the universe? At the end of this journey, the simulation forces us to look at everything from a different perspective. At first, the idea seemed simple. Move our solar system to the center of the Milky Way and observe what would happen. But after seeing Earth under a strange sky, Saturn with its rings in front of the heart of the galaxy, Jupiter surrounded by a region filled with dust, stars, and extreme gravity, the question changes. It's no longer just about knowing what the planets would look like. The real question is much deeper. Why can an impossible scene help us better understand the real universe? Because this simulation takes something we normally feel is distant, abstract, and difficult to imagine, and transforms it into a visual experience. Sagittarius A* ceases to be just a scientific name. It becomes a presence. The galactic center ceases to be an invisible point on astronomical maps. It becomes a place we can imagine, even if we can never actually visit it. The answer lies in scale. Our solar system is located in a relatively quiet region of the Milky Way, far from the galactic center, far from the highest concentration of stars, and far from the direct influence of the supermassive black hole. That distance is no small detail. It's one of the reasons why our cosmic neighborhood is stable. Earth doesn't just need water, an atmosphere, and the right distance from the sun. It also needs time. Time for oceans to form, for life to evolve, for violent impacts to subside, and for orbits to remain sufficiently stable for billions of years. If our system were near S2, in a region where stars move at extreme speeds around Sagittarius A*, the scenery would be breathtaking, but stability would be far more precarious. The beauty of the galactic center would come with risks: gravitational encounters, radiation, dust, hot gas, and orbital motions far more violent than those in our current region. Now the question is for you. Would you rather live under the tranquil sky we know today, or gaze each night at the galaxy's central black hole? If this journey has given you a new perspective on our solar system, subscribe to the channel, like this video, and comment on what other impossible simulation of the universe you'd like to see in the next episode.